JAMB 2026 candidates, if after I explain this question, the answer to this question that you are seeing on the screen, and you don't understand, just know that you have village problem, or your forefathers are still owing your village people. So lend me your ears. Based on popular demands, I am going to explain this because a lot of students has been on the comment section asking me to explain. Please explain. Okay, here you go. You asked for it. You've gotten it. So what do you have to do now? You know we don't use textbooks here. We know they use textbook here. I know they stress students. I don't stress students. If you want to pass your JAMB UTME, you want to score high in your JAMB UTME without stress. If you're a kind of student that hates stress, come to my page. Come to my hall. Take my short lectures. Get your pen and your paper. Write when you are taking my lectures. Jot down, because those things you jot down, you are going to use it for subsequent revision. Definitely 3 weeks to your JAMB UTME, you bring all you've jotted down and study them, revise your past question, and you are 100% ready to take your JAMB UTME and score 300 plus. I will fortify you for your JAMB UTME 2026. So let's look at the question. Get your pen and your paper and let's go. JAMB must repeat question 8. Look at this chemical equation we have here. The right hand side of the equation is on the ionic form, while the left hand side of the equation is in the state of matter. So let's read. The bond between sodium and S is likely to be what? The bond between sodium and X is likely to be what? A, covalent, B, dative, C, ionic, D, metallic. The big question now is, how would you know the elements that this S represents? It's very easy. Very, very easy. I will teach you how to do that. But first of all, let's understand the types of bond, because even though you know the element that is supposed to be here, or this mystery element represented with X, and you don't know the type of bond, you don't understand bond, you don't understand chemical bonding, what it is, what it entails, you are going to be lost. You are going to be lost. You are still going to end up picking the wrong option. So let's understand the types of chemical bonds. First of all, let's define chemical bonding. What is chemical bonding? Chemical bonding is the force of attraction that holds atoms or ions together to form molecules or compounds. So chemical bonding is like the foundation of the force of attraction when dealing with chemicals. Okay? When dealing with chemicals, it's like the foundation of the force of attraction when dealing with chemicals. Because here we are dealing with chemicals. Remember, there is also physical bonding or physical bond. Okay? But here we are talking about chemical bond. Physical bonding is like carry candle and rice. You melt candle, pour rice inside. That's a physical bond. Because when it cools down, you get a bond. Okay, but when you heat it up, the bond is dissociated, the bond is broken. Okay, that's a physical bond. Okay, you see it, kuru, the bond is broken, nothing changes, everything remains the same, everything is recovered the same way it was added. Okay, the same way you put them together, that's the same way you are going to recover them. Everything is recovered whole. That's a physical bond. But in a chemical bond, there must be a chemical process for you to break the bond with a physical process. Okay, if you are breaking the bond through heating, there must be a chemical process that will occur. Okay, there must be a reverse reaction or whatever is going to chemically go on there for that bond to be broken. Have I made myself clear? So like we said, bond is the force of attraction. Chemical bonding is the force of attraction between two atoms. Between atoms to form what? Molecules, compounds, or so this force of attraction is between atoms or ions. Take note of that, between atoms and ions. So atoms bond to achieve a stable electron configuration. Okay, so usually octet or duplet normally. So when atoms bond, hey, you understand, it's a redox process where this one donates, this one receive, or they share. Whatever type of bond that occurs, that is chemical bonding. Hope I made myself clear. Chemical bonding rules. We have two major rules in chemical bonding. We have the octet rule and the duplet rule. The octet rule. Oct means 8. Oct means 8. Okay, oct. So what does the octet rule imply? The octet rule implies that atoms tend to gain, lose, or share electrons in order to have 8 electrons in their atomos share, like the noble gases. So 8 electrons in their atomos share, they either gain, lose, or share electron to have 8 electrons in their atomos share. Like I said, oct, the meaning of oct is 8. So anytime you hear oct, just know that is that chemical bonding rule that an element either lost, gain, or share electron to have 8 electrons in their atomos share to achieve that stability. And once they have 8 electrons in their atomos share, they are stable. They are stable. So this is very common among the noble gases. They are very common among the noble gases. If you have not taken my lecture on periodic table, please do well to hit the link in the description and take my lecture on periodic table and periodicity. Then the second one we have here is the duplet rule. And the duplet rule, atoms with only the first shell, like atoms having only one shell, like hydrogen, helium, and lithium, tends to gain, lose, or share electron to have 2 electrons in their atomos share. So they gain, lose, or share electron to have 2 electrons in the atomos share. So that's duplet for you. That's duplet for you. Usually obeyed by those elements with only one shell, such as the helium, the hydrogen and the lithium, and so on and so forth. Let's look at the types of chemical bonding next. The types of chemical bonds. The types of chemical bonds. The first we have here is the ionic bond. It can also be called electrovalent bond. Why is it called ionic bond? Because it's a bond that involves the exchange of ion. That's why it's called ionic bond. Involves the exchange of ion. One receives, one takes. One accepts, one receives. It's the bond that occurs from a redox reaction. Ionic bond is the aftermath of a redox reaction or a redox chemical process. So let's look at the statement we have here. It's the transfer of electron from one atom to another, leading to the formation of oppositely charged ion, which attracts. So an electron is transferred from one atom to the other. One receives, one gains, a redox process. Both atoms are usually oppositely charged. Okay, one is positively charged, one is negatively charged. No two electrons, like no two positively charged electron or negatively charged electrons can form an ionic bond. No, ionic bond can only be formed by different charges, negative and positive charge. It can never be formed between positive and positive charge or negative and negative charge. No, it must be opposite, negative and negative charge, because there needs to be a transfer of electron. And remember the law of charge. It states like charge repel, unlike charges attracts. So they occur usually, because of this characteristic here, that tells you that they occur usually between metals and non-metals. So ionic or electrovalent bonds occur between metals and non-metals. Remember, metals are electropositive. They are positively charged. Non-metals are what? Negative. They are negatively charged. They are electronegative. So between negative and positive, but can never occur with the same charge or similar charge. So any element or compound involved in electrovalent bond or ionic bond are called ionic compound, or you can call them electrovalent compound, whichever name between both of them, electrovalent compound or ionic compound. So now let's look at the features or the properties of ionic compounds. Number one, high melting and boiling point. Remember, most of them are solids. Two, conduct electricity when molten and aqueous. So when molten, okay, when in solid form, okay, like they are not in liquid form, but they are not in solid form. That's molten form, okay. They conduct electricity. Remember, they are ionic compounds. That tells you that they are compounds that conduct electricity because of the presence of ion. Ion possess charges, and they are like the carriers of charges. Okay, that's ion for you. So you have to understand these concepts and think deeply, and you are going to easily find answers to all the simple questions in your Jamb TME. They are usually soluble in water. They are hard and brittle, like I said before, and they have strong electrostatic attraction. Strong electrostatic what? Attraction. Examples include sodium chloride, magnesium oxide, calcium chloride, and potassium bromide, and so on and so forth. We have numerous ionic compounds. So let's look at covalent bond. Number two, covalent bond. Take note of the color coding. What is covalent bond? It's a bond that involves the sharing of electron pairs between non-metal atom or non-metal atom. So this bond is a bond between two negatively charged atoms or two negatively charged elements. Unlike ionic bond involving positive and negative, there must be opposite ions. But this one is two same ion, negative and negative, negative and negative ion. And the electrons are shared, unlike the ionic bond where one will donate, one will receive. The chemical process of covalent bond is not a redox process. Electrons are not transferred, but rather they are shared. Yes, atoms shares electron to achieve this octet or duplex stability or whatever. And the types include, there are three types of covalent bond. The first we have here is the single covalent bond, share one pair, okay? Just one pair of the electron is shared. That's the meaning of single covalent bond. One pair of the electron is shared. We have the double covalent bond where two pairs of the bond is shared, double bond, okay? Which is the molecule of oxygen, for example. That's why you have O2. Then you have the triple bond where three pairs of the atoms are shared, such as the one you have in nitrogen. So it's having this triple bond, okay? Triple covalent bond. So we have single covalent bond, double covalent bond, and triple covalent bond. So any element or atom that is involved in covalent bonding forms covalent compounds. So let's look at the properties of covalent compounds. What are the properties of covalent compounds? Covalent compounds are most common in organic chemistry, while ionic compounds are most common in inorganic chemistry. So they have low melting and boiling points, do not conduct electricity. No, they don't conduct electricity. No. Because you don't have ions present. It's not the bonds that involve the transfer of ion. So such compounds are not electric conductors. They are not conductors, okay? They don't conduct electricity. So they are usually gases slash liquid slash soft solid. They are usually gases, they are usually liquids, they are usually soft solids, okay? They can be gases, they can be liquid, they can be soft solids. They are poorly soluble in water, except some polar covalents, When you hear anything polar, just know that it's water seeking, okay? It's something that loves water. It loves water. It's involving water. Polar solvents, polar covalents, okay? They are soluble in water. So when you hear polar covalents, though they are soluble in water, they are not soluble in water except for the polar covalent or polysoluble in water, like benzene. Benzene is insoluble in water. Let's move over to the next bond, which is the coordinate bond. And the coordinate bond can also be called dative bond. Dative bond. And what is coordinate bond or the dative bond? A coordinate bond is a covalent bond. So it's a type of covalent bond. That's why it's treated, we are treating it just immediately after covalent bond. So coordinate bond is a type of covalent bond where that electron that is shared in a covalent bond, in covalent bond, electron that's shared, okay? Electrons are not transferred, rather they are shared. That electron that is shared, instead of the two pair of electrons that is shared, instead of the two atoms involved in this bond, this covalent bond, to donate that two pairs of electrons that are to be shared by these two atoms to form covalent bond. You know what happens in coordinate bond? Only one will now donate that electrons that are to be shared among them. That makes it a coordinate bond. And such bond is a very weak bond. It's weaker than the normal traditional covalent bond. So just know that in coordinate bond, you can be calling it coordinate covalent bond. In coordinate covalent bond, so that you will not forget, coordinate covalent bond or coordinate dative bond, the electrons that are to be shared is donated by one atom. One atom donates all the electrons that are to be shared. Okay, that's it. What are the examples of coordinate bond or coordinately bonded compounds or datively bonded compounds? We have the ammonium ion, we have the hydroxonium ion, we have the carbon 2 oxide, we have the sulfur 4 oxide complexes, we have the oxyhemoglobin for the biochemical processes, oxyhemoglobin. Let's look at metallic bond. Metallic bond. What is metallic bond? It's very easy, very simple. This is like the simplest. It's an attraction or force of attraction between positive metallic ions and a sea of delocalized electron. That's it. Okay, so covalent bond is between two negatively charged atoms, but in metallic bond you're having two positively charged atoms. Have I made myself clear? So bonding is very easy. Chemical bonds are very easy to understand. It all depends on the person that is teaching you. That's what is going to determine how well you are going to understand it and how well you are going to apply it in your examination. Okay, so let's look at the properties of compounds with metallic bond or compounds or elements where metallic bond exists. They are what? They are good conductors of heat or electricity. They are malleable and ductile. They have high melting and boiling points. They are shiny and lustrous. These are typical properties of metals. These are typical properties of metals. Now, let's look at the types of covalent bonds. Still under the types of covalent compound, very important for Jamb. Jamb loves setting questions from these, okay? So we have the non-polar covalent and the polar covalent compound. The non-polar covalent compound and the polar covalent compound. On the left-hand side of the table, we have the non-polar covalent compounds, while on the right-hand side of the table, we have the polar covalent compounds. On the left-hand side of the table, the non-polar covalent compounds, their features or their properties, they have equal sharing of electrons. Equal sharing of electrons. No be one person, the donator. Okay, is equal. Okay, if they are sharing two pairs, they are sharing that two pairs completely. If they are sharing one pair, they are sharing that one pair completely, and so on and so forth. They have identical atoms. For the non-polar, identical atoms. Hope you are penning down. Hope you are making your notes. They are insoluble in water. Insoluble in water, not soluble in water. Non-polar. Does not love water. Does not involve water. Non-polar. Examples include hydrogen molecules, oxygen molecules, nitrogen molecules, chlorine molecules, and methane molecules. Then on the right hand side of the table, we have the what? The polar covalent. And the polar covalent compounds are, there is an unequal sharing of the electron, okay? The electron that they normally share to form covalent compound. There is unequal sharing of dipoles formed. So dipoles are formed. So when they ask you in which of the bonds are dipoles formed, is what? Polar covalent or polar covalent compounds. That's where the dipoles are formed. That's two poles are formed. Examples of polar covalent, you have what? You have hydrogen chloride gas, you have what? Water, you have what? Ammonia, and so on and so forth. Let's now look at the weak intermolecular forces. The weak intermolecular forces, or they are also called the weak bonds. So these are treated differently because they are not force of attraction between atoms, unlike bonds. But these weak intermolecular forces are force of attraction between molecules and not atoms. Okay, for bonds, chemical bonds, they are between atoms. But for intermolecular forces, they are weak bonds. They are force of attraction between molecules and not bonds. The first we have here is the van der Waals force. And the van der Waals forces is a weak forces of attraction between non-polar molecules. Between non-polar molecules, between non-water seeking molecules. Molecules that does not love water, molecules that does not have water in it. They increase with what? With molecular size. they increase with what? Molecular size. Examples of compounds or elements with the van der Waals forces as a weak bond. Examples include the noble gases. Okay, the molecules of the noble gases, they are held together by the van der Waals force. You have the halogens, the molecules of halogens held together by the van der Waals force, and the molecules of graphite too held by the van der Waals force. These van der Waals forces are responsible for the lubricating property of graphite. Graphite is a solid lubricant. Then number 2 here, under the weak intermolecular force, we have the dipole-dipole forces. The dipole-dipole forces are force of attraction between polar molecules. So between non-polar molecule is the van der Waals forces. Then between polar molecules is the dipole-dipole what? Forces. Between polar molecules, dipole-dipole forces. So that's it. And the examples include hydrogen chloride gas and sulfur 4 oxide. Now let's look at the third one under the weak intermolecular forces. The third one is the hydrogen bond. And the hydrogen bond is still under the weak intermolecular forces. It's the force of attraction between molecules of a substance, and is the strongest weak intermolecular force among all of them. Hydrogen bond is the strongest, and you have to know that for a fact for your exam. So it occurs when hydrogen is bonded to what? To nitrogen. Hydrogen is bonded to nitrogen or to oxygen or to fluorine. It forms what? Hydrogen bonding. Examples of compound where hydrogen bond exists are water, hydrogen fluoride, and ammonia. Importance of hydrogen bonding. They include, what are the effects of hydrogen bonding? High boiling point of water. They are responsible for high boiling point of water. Hydrogen bonding is responsible for the high boiling point of water at 100 degrees Celsius when the water is not hard, okay, for soft water. Ice is less dense than water because of hydrogen bonding. That's why ice floats on water, okay? Ice floats on water because it's less dense than water. Because of that hydrogen bonding present, it floats on water. And DNA stability. The stability of DNA is as a result of hydrogen bonding or hydrogen bond. The stability of DNA, deoxyribonucleic acid, is as a result of hydrogen bond. Now, let's look at electronegativity and bond type. Large electron negativity difference for elements with large electronegativity difference. Maybe this one is very reactive, this one is weakly reactive or poorly reactive. Then such bond that will exist between those two elements or substances is ionic. When one is highly reactive, the other one is poorly reactive. So you should expect ionic bond. This one is another expo for your Jamb UTME. Then small electron negativity difference. Okay, so when the two elements or the two substances under reaction, they don't have much difference in terms of reactivity. Both of them are almost similar in terms of reactivity, in terms of the extent of reaction. Okay, then the bond that exists between such kind of compounds is polar covalent. Then when there is zero electronegativity difference, both of them react closely with each other. Equal reactivity. Just know that it's a non-polar covalent bond that will exist between the two elements or the two substances. Short notes for Jamb. Why does metal conduct electricity? You can see this in your Jamb UTME. Because of free/delocalized electron. Their electrons are free in the orbitals of the atoms. That's why they are able to conduct electricity seamlessly. Then another question here is, why ionic compound conducts only when molten? Why? Because ions are free to move. When it's molten, when it's in molten form, when it is like in a solid form, ions are free to move. Other than when they are in solid forms. Ion can't move now. The ions can't move. The ions are static. So when you make the compound molten, when you add water to it to make it a little bit in a gel form, it conducts electricity more. Then the next question here is, why covalent compound have low melting points? Why? Because of the weak intermolecular forces. The weak intermolecular forces. That's the reason why covalent compound have low melting points. And the final question here is, why ice floats on water? Why ice floats on water? Because of the hydrogen bonds making ice less dense. Because of the hydrogen bond presence in water, it makes ice less dense. So when water forms ice, it becomes less dense because of hydrogen bond. Now, let's go back to the Jamb repeated question 8 that brought us to this topic of discussion. Jamb repeated question 8. The question reads,